Howdy. So here we are at soil conservation. This is probably the first real environmental science lecture. Now that we've spent a lot of time talking about the earth science basics, we've had an introduction to what soil is. Now we're going to talk about what are we doing as humans and why it's important for us to look at soil conservation in light um, of all of the things that we've been putting together and learning. Soil conservation is a necessary topic to begin to introduce because we as humans we use soil. We use soil to grow our food. We use soil to build upon, and we don't necessarily have a good history of taking care of the natural systems that surround us and protecting what we call ecosystem services. These are things that are required. These are processes within the natural world that provide us with things that we need, and they are really required for us as organic beings, as humans. We really need to see these processes stay healthy and stay in place. So one ecosystem service would be the growth of food for us. Now we have introduced um, a more efficient method in our agricultural practices. So it's super efficient, but some of the trade-offs is that this really efficient system, industrial agriculture, it damages ecosystems and it damages soil in ways that we must address as humans, as a society, in order to continue to use the soil for growing food. So we've got some problems that kind of loop in um, to the way that our society is set up. It's something that we're aware of in current human society, and it's something that we're seeing change over time now that we understand the need for that. So, what are some of the ways that humans destroy topsoil, which is a super valuable resource? And we talked about the fact that soil takes a long time to produce. Some of the ways that we interrupt that um, really do come from agricultural practices on an industrial level. The big one is erosion. So, we sometimes really accelerate erosion. Erosion is a natural process, but when we remove the plant matter that covers soil, we make that soil exposed to the elements. Like we expose it to wind and we expose it to water. And one of the things that plants do with their root systems with soil is they hold soil in place. And when we take those plants out through tilling soil, it means that now that soil is exposed and it is vulnerable to the process of erosion, where that topsoil will then, it can get blown away or it can be washed away through the process of runoff. The other threat is compaction. So when we're driving or walking over soil in the same place over and over and over again, it removes the spaces that we defined in the lecture on soil. I was talking about that soil aspects of soil. One of the aspects of soil is the pore spaces that are in soil that allow for roots to move and grow through it. It allows water to seep through it. It also, when the water's not moving through it, then there's air in those spaces, and it allows the plant to get oxygen and CO2. And it really, like, they need plants need those pore spaces in the soil. If it doesn't have it, things won't grow. If soil is overly saturated, you can see that plants can drown, they can die. Sadly, I have a house plant that got overwatered, and it probably sat in that water, and it's not a plant that's adapted to sitting in water. And so you can look at the windowsill, there's a little house plant. It was super duper cute until it sat in too much water. And we'll see. Maybe there's a part of it that's still alive. I'm holding out hope. Maybe it'll grow back. Sometimes that happens, but you can see the damage that not having those pore spaces causes. Another threat is salinization, and salinization really occurs when we take water from rivers or from the ground that has dissolved salts and minerals in it, and we use it for agricultural purposes. And when rain falls, there's not salt in it because that's water that has been evaporated, condensed in the air, and then is falling over the land. It's pretty pure for the most part. It does pick up some particulate matter, like acid rain and things like that. But like once that gets washed out of the air itself, then like lots and lots of rain, it's very pure water and it can actually like help wash soil out. But if you don't have enough rain in an area and you're using irrigation to water plants, one of the threats is that there may be an accumulation of salt in the soil, so much so that sometimes soil becomes unusable and it is not able to be used for crops because the salinization is so high. Sometimes further down a river from the headwaters, that's where a river will start, all the way down to the mouth of the river where it enters into the ocean, or enters, sometimes some rivers will dump into a lake. Um, if if you test the saline capacity or the saline level of rivers, like at the headwaters, it'll be really pure and low in salts. But as the water moves over the land, it dissolves those minerals and rocks that we've been talking about. And those salts get taken up in solution or they're suspended in particulate matter within the river, and that water is used to irrigate fields. Then that water evaporates off the fields or is taken up into the plant, and the salts are left behind and they concentrate within the soil. And that accumulation of salts within the soil makes the soil unusable. This is a difficult issue when we're looking at, like we say, downstream, right? Where um, societies that are further down from the source of a river will deal more with salinization issues. Um, so going back to erosion, there are 3 types of wind erosion that we need to discuss and get into your notes. They're defined by the way that the particles move. And so this really kind of comes into play, like how strong the wind is and then how small the sediments are, is going to determine like what actually happens, the action of those materials. Creep is when soil particles will just roll or slide. So they may be a little bit heavier or the wind is not as strong, but it may be pretty steady. And they just roll and slide, but they maintain contact with the ground, but they'll still move, and this still causes soil loss. Saltation is when grains of soil will actually be picked up by the wind, but they're just heavy enough to kind of like bounce along. And then suspension is when soil will pick particulates up and actually move them through the air, and like in a dust storm, and we'll just pick up all the dust. And one of the case studies that I want you to be aware of is the great the Dust Bowl. That really was key in, it didn't cause the depression. There were a lot of political and economic things happening within the country, within the U.S. During the Great Depression, but it really kind of was like a trigger. It was like the straw that broke the camel's back. This was something that happened in the Midwest, where practices in agriculture weren't really centered around creating healthy soils or maintaining healthy soils and conserving soil. Farmers did not really understand everything that they were doing. They really looked at what was most efficient, and they would till in ways that exposed the land to the wind and the rain, and the Dust Bowl just picked up all of this soil and basically moved it, took it away. Water erosion. So there are 5 types of water erosion, and we're talking about erosion from like more of like an like a human standpoint in terms of like how we use the land and why erosion, and water erosion specifically, is a threat to the health of our land and the health of our soils. So these 5 types of water erosion really are talking about like how water affects fields, right, and where we're growing crops. So sheet erosion is a loss that is uniform. It's that top thin layer, and it's over a full field, and it may be because of irrigation practices or maybe like heavy rains. Sometimes that's pretty even, and that's just like constant surface all the way around. Um, and then like the next level would be that rills form. So these are kind of sequential. Like sheet erosion happens first. If it continues to erode, you're going to see rills show up. These are channels, or rills are small, that will form. They can be randomly located. Usually it's just because there's an area where water kind of collects and moves a little faster in one area, and it begins to move materials, and gets, I mean, you've seen this happen. It gets deeper and deeper in particular areas. Ephemeral erosion is further than the rills. Once the rills start to really get into place, you get like deeper channels and depressions that form. And this may happen year after year when there's a heavy rain in a particular area, and then you begin to see the evidence of water erosion, not just for a season, but over and over, and maybe multiple seasons in a row. Um, then we have gullies. Gullies are large channels that are now not able to be repaired by tilling fields. So all of the three before, you could go back in, till a field, flatten things out. But then you're in a cycle of having to till the land to flatten it all back out and to make it available for agricultural use. Now, gullies, they cannot be repaired by tilling. Now you have something where water's flowing on a regular basis, and a gully starts to form out, and it's deeper, and basically all the topsoil has gone. There may be multiple horizons that have been stripped out, and that wouldn't be an area that you would see growth happening anyways. And then stream bank erosion is when the sides of a stream over time, you can see here, this is an example of stream bank erosion, um, especially in the far end of the picture. So I'll put my little face up here. See, looking down there, you can see that it looks like parts of that stream bank have actually fallen into the water, and that's probably true. Over time, that water is a very powerful agent of erosion, and so it's just falling away, and the banks will fall in, and the river gets bigger and bigger, and then all the water kind of collects in that lower area. Soil conservation is super important because it takes hundreds of years for 1 inch of topsoil to be created. And it can take even longer in areas that don't have a lot of organic matter, don't have a lot of rain. And so it's not contributing any organic matter to the soil. Soil's being lost 17 times faster than it is being formed. And that's because of human practices. So heavy tilling actually makes it more difficult for us to grow good food. We might be able to grow food, but it's not nutrient dense because the soil has all of its nutrients stripped away. Heavy tilling can compact soil and destroys topsoil. Heavy tilling can also kill microorganisms. In the soil lecture, I discussed the fact that soil is more than just sediments. Soil is a collection. It is a very dynamic mix of sediments of different sizes, clay, sand, and silt, organic matter that is dead, and then the microorganisms that are feeding on that organic matter. It all mixes in there together and makes nutrients available to plants, and the roots will grow into that soil, and those nutrients will move into the root system and help feed the plant if they're there. So microorganisms are extremely important for recycling the nutrients that are in organic or dead organic matter and making it available to the living things that are growing in the soil. To make soil suitable for growing crops, if it's been stripped away and it's been overused in agriculture, it takes commercial fertilizers, things have to be added to the soil, and really it's almost not soil. It's like very artificial at that point. Farming methods that can be used to conserve soil: conservation tillage, crop rotation, contour plowing. And you have spots in your notes for all of these to have some explanations. You can see this is an example right here known as no-till farming, that it's just less till farming, but it doesn't strip away the plants. It leaves those plants there to feed the next generation of plants. Another method is conservation buffers, windbreaks, which we see in California all over the place in our agricultural areas. Terracing. Terracing is a stair-step effect that's created to slow water runoff. Terracing is part of traditional agricultural practices that we see in historic places like Thailand and China. And then wetlands, when wetlands will catch and hold water to slow erosion. These are all ways, like conserving wetlands, employing terracing, Employing some of these methods help us to offset our impact through agricultural practices on soil. So here's